Good morning, everybody, and thank you to Cork, or IT at Cork, for inviting me to speak here today. So I'm a bit like Andrew, not an IT professional. I'm the Director of Process Development for Boston Scientific here in Cork, but I have quite a big passion for data analytics because I see this as being very instrumental in how our business is changing and evolving as we progress into this fourth industrial revolution. So you'll see very much that as we pass through the three previous industrial revolutions, we've meet a convergence point where technology and digitalization is really what's driving this fourth revolution. And it's allowing us the ability to create a virtual world that yet can steer the physical world that we work in. And key to all of this has really been the development of the internet and all of the technologies that have come with that, such as the Internet of Things, the connectivity aspects of that, the cloud, the ability to share and communicate across multiple sites, platforms, and areas, and ultimately the big data analytics that goes with that to allow us to optimize production systems and to drive out inefficiencies within our manufacturing processes. So Industry 4.0, where did it begin? So it was a phrase really coined around 2012 in Germany, and since then it's spread rapidly across the European countries, where many countries now have initiatives into the introduction of the Industry 4.0 applications. But what is it really? There's no real clear definition or no clear agreed definition of what Industry 4.0, and I think that's, to Andrew's point, is that each company in each area needs to understand what it is that's relevant to their business and their manufacturing that really they want to actually adopt. So for me, it's both a bit of revolution and evolution of the current manufacturing processes. It's allowing us to move from very much a paper-based transactional processes to more digitized platforms that are driven around data analytics, ultimately designed to improve productivity, eliminate inefficiencies, and to deliver improvements for our customers. So what's at the heart of all of this? For me, it's data. That's what's driving the transformation. So we have the Internet of Things that provides the ability to connect and sensorize everything from both our supply chain to our products to actually our processes, and then generate lots of data around that. Where do we store that? You can optimize it through our own internal servers or out through the cloud, and that really helps us be able to share and transfer that data across multiple sites and learn from other aspects of our own business. Through that, we use simulation, so both in product development and actual new process development, we look at simulating that virtually before we actually invest heavily from a capital perspective on actual new production processes, so we know that when we're going into production, it's born lean, and that's a term that you'll hear a lot within Boston Scientific about optimized processes going into production from day one. But with all of those things, we have to be very much mindful of cybersecurity. So the days of unconnected, protected systems is no longer the case with the advent of the cloud and the Internet of Things. The connectivity and the communication is as big a threat as actually the advances that it helps us in making productivity improvements. So cybersecurity is of paramount importance nowadays, and certainly within a regulated industry such as ours. Key to that is the data analytics. So we generate large amounts of data now every day. In fact, as I walked from here, my watch was beeping at me. So my watch is telling me I haven't walked enough steps yet, and it told me I should have moved in the last hour. That's going to upload to my smartphone later on when I connect to that, and ultimately I'll have data analytics about what I did today. So this shows the level of connectivity and data being generated by every person in this room, and that's only going to expand as we go forward. Additive manufacturing, so there are colleagues here I see from Stryker, so I know there's lots of investment being done in terms of additive manufacturing and ultimately customized manufacturing for healthcare products, where now you can print the product that's suitable for the person as opposed to producing products over a range of different things, and that's really driving improvements in actual ability to actually serve the market better. Augmented reality, you'll see from Action Point the introduction of the HoloLens, and this is something that's really revolutionizing our ability to train people in a virtual environment and actually give them more real-time information about the processes that they're using in a different manner. And also cobotics. This is particularly important as we move forward into manufacturing 4.0, and the interaction of robots working alongside people in conjunction with them in a safe environment that allows us to improve their ability to do their jobs. So what are all of these things doing for us? So they're really helping to drive a business transformation. So they're allowing us to do different things faster and more agile approaches to product development. It's creating customization. It's ultimately getting to that holy grail of a batch size of 1. And ultimately, what these are doing is driving new business processes across our business, and the data that's generated from that is helping us to optimize that as we go forward. This allows us to have better vertical integration in our own production processes, but also in horizontal integration across our supply chain networks and with our partners in that processes. So really starting to transform the speed at which we do business. But just from a data generation perspective, so this is an example of a facility in Minnesota, which recently, it's been in production for over 15, 16 years now, but recently they did an analysis and realized that they've only just created their first terabyte of data. Quite hard to believe that actually in this day and age, when you consider that an average manufacturing line for Intel produces a terabyte of data every 15 hours, and the Large Hadron Collider in CERN produces a terabyte of data every 15 seconds, or 15 minutes. So this is a scale of how data is actually starting to change in different industries, and yet we see this more and more as we introduce new manufacturing processes. New technologies have capabilities that we're not fully exploiting, and that's really where the data analytics aspect of it comes into. We can create the data, but how can we analyze it and what can we do with it? So I want to start with this picture. So can anybody quickly tell me what that picture is of? What does it mean? What is it? It's an animal. I'll give you a hint. Come on, anybody? Giraffe. It's a giraffe, very good. So very quickly you made an association that that's a giraffe. Not quite your average giraffe, it might be one that needs to go through operation transformation, but nevertheless it's a giraffe, based on the fact that the pattern recognition you saw on its fur, its very distinctive head, the scale of its neck to its body, albeit maybe not quite in the right proportions, but you very quickly were able to use that data that you've collected over many years from experiences to see that that is an actual giraffe. But how do you teach a machine to know that that's a giraffe? How do you tell it that that's what it needs to look for? So we've now started to move into neural networks and the introduction of using neural networks as a means for actually doing actual visual inspections. So it's a method of machine learning. It's example-based, so we're teaching machines, but they're self-learning through algorithms on actually what are differences in their products. So if this is a facial recognition algorithm, so it's built about two things. One, they're either geometric, so it looks for specific differences that you've told it to look for, or it's photometric, where it starts to do statistical analysis on what it thinks it should be looking for. So you classify it. It's a series of outputs and nodes built around virtual neurons, and it can transfer data back and forth multiple times, so it can iterate its own learning. The ability for this is that it allows us to look at improvements in our inspection. So a human inspection, visual inspection, is about 85% effective, and only over a short period of time. So the longer somebody keeps looking at something, the less likely they are to actually spot the defect. We found with this that we've got it to about a 95% inspection rate, and it actually improves from a 95% as you tell it that you've now missed a defect, and that was a defect that it was looking for. And it's increasing. So we're looking to ultimately have machines look at our products to ensure that we're not making defective products and ultimately putting our patients at risk. So this is the Gartner Analytic Ascendancy Model. So ultimately, we're starting on a journey. We're very good at descriptive analytics and diagnostics. We can always tell you what went wrong, why it went wrong. What my boss always tells me is, why didn't you know it was going to happen, and what are you going to do to prevent it? And I'm sure many people would hear that. So as we move up this chain, the investment and obviously the difficulty becomes greater, but the investment costs ultimately pay back. But that's the business case that you have to sell to your management teams, to say this is worth investing. It's worth investing in data analytics to understand and create these processes that ultimately drive better efficiency. So we're very guilty as engineers to always talk about the data and sometimes realize that not everything is a 1 and a 0. That actually at the heart of all of this is people, because it's people that will make the changes here, not the equipment. And ultimately, there's 3 things that are really going to drive that. One is the technology awareness. So that's within the companies, understanding and clearly knowing what it is within Industry 4.0 you want to implement and why. When I say driven by C-suite, we're not talking about a type of programming language. We're talking about the corporate management structure. There has to be a willingness and adoption to actually want to embrace this technology and to invest in it. And then it's about having the right digital skills, so creating the culture and having the right people available to help you do this. But there are companies, there are areas out there to help you with this. So digital innovation hubs are around Europe, and they're also within Ireland. There's 2 specifically. I know Barry spoke about the Confirm Centre, which you can get details at the back. I also sit on the board of Irish Manufacturing Research, which is the other digital innovation hub. And our job is really there to help try and create centres of learning, collaborations with the likes of Action Point and with ITS and Cobotics, and to bring communities of learning together across industries. So IT at Cork being engaged with manufacturing in a medical device company or the pharma industry, and actually start to show our learnings and actually share those learnings to help drive that forward. So in summary, if I can tell you the 3 or 4 things that I wanted to talk about, was that Industry 4.0 gives us leverage to respond to market shifts, and it'll create new opportunities for us all. People and data are at the core of all of this. And the 3 main factors that will drive that is having technology awareness, being supported by your management structure, and having the right skill sets to be available to help you do it. And ultimately, there is help out there through the digital innovation hubs, and you need to reach out to them because they're more than willing to help. So thank you.